Now we are continuing with machine learning, improving data harmonization. Big data brings many benefits to the healthcare industry that can also be used in the context of artificial intelligence and machine learning for the further development of medicine. The idea of AI and machine learning for the purpose of data harmonization has not yet spread sufficiently. We want to change this as quick as possible, and we are able to change it. And it's my pleasure to welcome Dr. Christian Stephan, CEO at Kairos, for a presentation on machine learning, improving data harmonization.
Yeah, thank you for the kind introduction. So I substitute today Martin Peuker, who couldn't make it today to give this presentation. But I will tell you something about machine learning and the improving of data, especially for harmonization. So everyone is knowing it today that the new resource is even more the data itself. And this is already known by Google and Facebook and Microsoft and Amazon and all others. And this is already known, and the economists described this on 2017 in a newsletter. But why does it take so long for this to become understood and true in the healthcare sector? Because in the healthcare sector, we have even other necessities to do this, and it's not easy to do it directly or today in an easy way. So the healthcare sector generates an estimate of 2.3 exabyte annually, and the growth is even fast as well as in other sectors. However, the data remains untapped, and it's in some cases unstructured. It's a physician letter or something else. It's described in some cases even more on paper and is not digitized at all today. And therefore, it's not useful for research and development for even better therapies within the healthcare sector. So what we need is data harmonization, or at least we call it as well interoperability. So we need, in some cases, at first, a digitization, but also for structuring these data. So these unstructured physician letters, we have to cover the information who is necessary for the physician to make their decision on therapies or diagnosis. And we have to harmonize these information. So often it's the same mean, but it's called different, or it's used with a different vocabulary. So in some cases, we have already digitized these data stocks, but it's not shared. And so no one can use it. And it's, again, untapped for medical research. And in some cases, it also happens that the data protection barriers has to be overcome. So not directly the data protection itself, but in some cases it's too hard, or it's too hard interpreted. And so in some cases it's also used to do or not to do something with the data, but it's already possible to do that. So we have today a gap of expectation and reality. So the expectation today is the interoperability. The data stream is going all over the world. Everyone can connect each other, and the data flow is very easy. But mainly it looks different. The reality is that we're drowning in this information, and we have also to structure this information and to make it free accessible, of course, only in a pseudonymized way, not only in the way that we can identify the person, the patient behind that, even more only by pseudonymized data to understand the disease behind that, not the patient behind that. So we have to evaluate our medical data, and we need good co-working structure and semantic interoperability to evaluate these data, and to have even a big data to use AI at least to even better come to better therapies and diagnostics. So the harmonization is one of the big things, but also the possibility to use AI, because it's already known that AI will save life, or is in some cases doing this already today. So big data can support the development of successful AI systems who are able to make medical research even faster on pseudonymized data. And we can provide these outcomes as well for the healthcare system. So at least also AI can revolutionize the healthcare sector by gaining new insights to the diseases of our time and future. And no one today will neglect this, because we know not even enough about COVID infections, about the outcome of a distinct patient. Some of the patients take it easier, but some of them has fatal diseases and going to death, and we do not know why. So just to describe, what is AI in the medical sector? So of course it's coming from the informatics, and what we try to do is to automate some intelligent behavior and machine learning. And that's the very important part, that we try to simulate more or less a human decision structure to represent intelligent predictability. So the ability of an AI system is to deal as well with the uncertainty, not only with a rule and a strict pathway, even more with the unexpected or a probabilistic information. So, however, the ability to learn is the main requirement of an AI system. So, but let me give you a short overview. So in some cases, there's a misinterpretation of AI. So this is neither learning or nor foreseeing. So you see, we have different cool dioxide measurements within our air, and we can see there is an up and down, and we thought we have understood it, but it's not foreseen that on 1950 it goes up so straight. And this is not AI. This is not able to foresee. And it's also not AI if you have any kind of correlation. You see data, it goes up or goes down and has a rule more or less behind that. That's again not AI. What AI is the learning. So everyone is knowing AlphaGo. So it's a game, and they have several algorithms already in place. And what they do is, okay, we're starting again from scratch. We use our first algorithm, AlphaGo, and let learn a new algorithm with no rules, with no restriction, and play against the other ones and learn by this the game. So it's starting, and after 3 days, because they can even play games even faster than ourselves, they have the first algorithm, AlphaGo Lee, reached, and would be even better. And after 40 days, they are even better than the AlphaGo algorithm, who struggle the best AlphaGo Go player in the world. And they believe no human will beat this algorithm in Go. So that is learning, and this is AI. And why do we need this? So just let me explain you in a simple way. So we have these pictures, and if someone should tell you who will be the person behind, then you can't do that. But by learning this, an AI can reconstruct the picture and can say, okay, it seems to me that it could be this person. And if you have this picture and see the original one, then you can see it's really, really close. And that's unable for us as a human to do that. It's only possible by using AI solutions. And that's the same also today possible. So some years ago, it maybe is not possible by a huge data amount to do that. So data and speed is the knowledge today. So that's the way we can go on as well for healthcare data. And let me give you a short first example. So the first one is, there was a publication on June 2016 by Bonnie Prescott. It's a Harvard public research, and it describes the accuracy of a pathologist versus AI for detecting breast cancer. So the machine learning is doing this with 92% accuracy. But the human is doing this even better with a 96% of accuracy. So the conclusion could be that the human are better than AI, and so please let the pathology do the job. Is that right? No, that's wrong, because if you combine now these AI solutions with the speed of the AI and the accuracy of the human, then we get an accuracy of 99.5% and an even faster result. So we can use both. So not only the AI will substitute any kind of other human being, it will help or make it easier for them to find solutions and to have even better, maybe later for physicians, even more time to speak with the patient, because the decision is taking not so much time as he's doing by their own. And that's very important. And give me a second example. So sepsis is one of the diseases that's today even more unknown. So we have, of course, today, maybe 9 people who will die in road traffic. Maybe not today because we have even smaller amount of traffic today. But however, if you look on the rate of sepsis patients who will die each day, then we will have 160 patients who will die today. And even worse, after they has overcome these sepsis, 35% of the patient who will die in the first year after a sepsis is a disease they're gathering on or have a treatment against sepsis. And we know something about sepsis, but we see that 4 or 5 people will die in a course of sepsis. And we could not say why this happened. But we can even better use AI as a solution to do that. And so what we have done is we collected data from a network of intensive care patients all over Germany. And we use the whole information, not only the disease, not only the ICD coding or something else, we use every parameter we can get from the patient about the oxygen and as well some blood parameters, and use them to treat an eye to distinguish between a patient who will die within the first 30 days or a patient who will not die within the first 30 days. And this is an answer or a question at least that a physician could answer, because we can do this with AI within the first 24 hours. We're measuring these parameters, and then we can tell you if the patient will survive the next 30 days. And that's the way we can use, again, the physician to help them to treat the right person. So to focus on them who has a fatal, at least, outcome of this disease, and even better to understand which one will be the good one who will more or less have a smaller or even better outcome of this disease. So you see that AI is today already possible and usable within the healthcare sector, but what we need at least is even better data, even better harmonized data, and even better sharing of data or free accessible data in a pseudonymized way to treat these kind of AI models and to have even better, at least, outcome for patients. And that's very important for the future. So what we need at least is a to-do list. So the lack of an infrastructure in the healthcare institute has to be or must to be overcome and eliminated. So the healthcare data must be recorded digitally directly at the bedside. The current digitized data must be shared, because then only new models and AI algorithms could be produced. And then we have to make these data interoperable, because the automated analysis of data could be only done if it's in the semantic same description, and we have interfaces to get these data out of several systems that are out there. And therefore, we have to increase the fragmentation or decrease the fragmentation of data, at least, because it has to be, this increasing fragmentation has to be stopped. So the excessive data protection must be as well overcome, because in some cases, we can't do these things however we are using it in a pseudonymized way. Of course, we need data protection. Of course, we need data security, but we have to think about the patient and the help we can do together at the day or 2 day. So thank you for your attention, and I'm happy to have even more questions about my presentation.
Thank you very much, Christian. Are there any best practice guidelines that you could recommend to hospitals that are interested in harmonizing data?
Yeah, there's no easy best practice because it's a long way to do. So what's happened in a hospital or healthcare sector is mainly the problem that we have several data carrying systems. So we have no standardization, we have a fragmentation of these data. And what a hospital or university hospital has to do in the beginning is to have a data integration. So just try to collect the data out from several systems. Don't substitute these systems, but don't let it increase even more systems, but bring it to one database, bring it into one, we call it data lake for using these data, and then share these data to not only physicians, but even more to researcher on informatics and as well, maybe a statistics side.
Thank you. We also have a question from the audience. Oliver is asking, what happens to the false positives? Is there any ethical justification for not treating a single person based on an AI decisions?
No. Yes, of course, there are false positives as well. That's the same like a physician is doing. But however, the AI will not substitute the physician. So it's a predictive possibility. It's a support, a predictive support for the physician. And as well, we have seen in this slide before, we also say, why do we do that? This is not a black box we are using for. We try to tell the physician as well, because we are thinking these parameters is running out or getting increased or decreased. We think about that these patients will be one of the problematic patients. And please decide on your expert knowledge about the strategies for therapy and additional diagnostics.
Perfect. We still have time for one last question. So is there any role for the regulator to play in order to advance data harmonization?
Yes, as well. This is a good question again, because this data harmonization is in some cases only done within one hospital, within one university. That makes sense, of course, to do that. But it's even better if you look even more for national or international standards. And we have already some semantics and ontologies already in place that all over the world would be used even better to describe as well diseases, describe parameters of the patient in a generic way. And if you do that, and you could do that on a starting point, then it's fine. But mainly it's not easy to do that, because then in his history you already have of data, you have to reference your data to these international used ontologies. And that's the way we can go on and further. And this takes time. It's not an easy and automated way to do that. So that's very important. And then you need as well researchers with the right knowledge as well in the healthcare sector to find the right reference between your term and the term is used in international ontologies.
Perfect. Thank you very much for being here today, Christian.
Thank you.